This is Unsiloed, brought to you by Alumni FM, connecting people through stories.
Okay, welcome to Unsiloed. I'm Greg LeBlanc, and I'm here with Bill Franks. And Bill just, I think you just launched this new Center for Statistics, Analytics Research, and Data Science at Kennesaw State University down in Georgia. Is that correct?
That's correct.
Yep. Yeah, and then you're also concurrently kind of Chief Analytics Officer at the International Institute for Analytics. You were at a company called Teradata for many years. And of course, you're the author of books, a couple books, Taming the Big Data Tidal Wave, which came out a while back. This one, which, I remember I bought this when it first came out, the Analytics Revolution. This is now about 6 or 7 years old. It was sort of right at that moment when data science was really coming to the attention of the mainstream, or the people I think of as the mainstream, which aren't really the mainstream. And you got a brand new book about ethics, right? It's what is it? The 97 things about ethics everybody should know. And I don't know if we have time to go through all 97 in the hour that we're here, but I don't have a copy of that one. I have actually a copy of Taming the Big Data Tidal Wave, but it's in a box somewhere, and I couldn't find it. I looked around and I couldn't find it, but I do remember it very well. So welcome, Bill.
Yeah, thanks for having me.
So I guess one of the first things I'd ask is, how does it feel to be in academia? Was that after being in business for so long? And I know you were kind of on the road all the time as kind of giving talks, and really you're an educator first and foremost, but now you're actually officially an educator. What's it like to be back in academia?
It's interesting, you hit on it. I've done consulting for many years, and I always really viewed what I was doing as teaching. I mean, it's a variation. It's not a classroom, obviously, but you're going in, talking to marketers or talking to operations people, trying to help them understand how analytics and data science could improve the business. And so I always enjoyed that aspect of it. So from that perspective, I think this academic switch has definitely been smooth and what I hoped and expected. It's fun. I'm actually teaching an applied project course, one of the capstone courses for the master's students this semester, with a real company brought in a real data set, and they have to work with it over the semester. And the final exam is presenting to that company. So the company themselves is going to effectively give them their grade as they rate those talks. So I think that'll be awesome. The other thing it also does is some of the writing I've always done around my day job and on the side, it's encouraged as part of your job at a university, obviously. So yeah, I'm looking forward to it. It's also nice not to be traveling around the world continuously like I did for a number of years. It gets a little bit tiring. It sounds glamorous to students and people have never done it. And then those who do it, there's very few people who do it for a while who find it quite as appealing as it was when they first started it.
Yeah, I've this year I've had to cut back on all that stuff too, and hence the podcast. So you've written a lot about data literacy, and I think maybe in the earlier stages of your career, when you were dealing with people who were technical, people who are in analyst roles, people who kind of lived and breathed data and business intelligence and so forth. You might have had to emphasize kind of business intelligence. I think now, when now that big data is something, I mean, I don't even know if people use the term big data anymore. Is there any other kind of data? Isn't that the only kind of data? Now that everybody's kind of in this world, I think your goal, and certainly my goal, is to create what we call data literacy. And I'm wondering if data literacy is kind of like the new sine qua non. I mean, it's like the baseline benchmark for being an intelligent manager now. Maybe, 50 years ago, it was being able to motivate people and inspire people. And now it's really like, if you don't have some kind of data literacy, it's hard to imagine that you can be effective. Is this something that, we have to make sure everybody has? I mean, here at Berkeley, we're trying to make sure that every single undergraduate, regardless of whether you're a poetry major or history major, has some exposure to data.
Yeah, well, let me take that at two levels, the individual level, then say the corporate enterprise level. At an individual level, I think you're absolutely right. Back earlier in my career, you might be talking to a marketing department and you'd have the quote data savvy marketing people and the non-data savvy marketing people. There'd be a mix. And oftentimes the people at the top were not the data savvy ones. And so the people underneath them would be who you'd work through and they'd kind of convince them to push the envelope. Frankly, I think it's hard to make it to the top of a marketing organization today if you're not one of the most data savvy, even though it's ostensibly a business role, because everything you're doing is permeated with data and the analysis of that data and the tracking of results, et cetera. So yeah, it's impossible in a work environment today to not have to interact with data in some fashion. And so I think what you're doing there in terms of requiring all students to have at least some fundamental understanding is a really good thing. Any student who has a natural interest in such things, I think to the extent they can pursue it above and beyond the minimum requirements, it's only going to serve them well in any role. Because even if you go to an extreme of a role that doesn't sound, highly data oriented, you might work for a nonprofit organization focused on fine arts events or something, and you go, yeah, well, that has nothing to do with data. Well, guess what? When you're running an event, you've got to track who you reached out to, who actually showed up. You've got to, you've got to track reviews that people gave whatever event you did. And so it might not be big data, it might not even be complicated data, but it's data nonetheless. And the decisions you make in terms of how to continue on that mission as that nonprofit still involve looking at what's working and what's not from a data perspective. So back to my point, at an individual level, you won't escape it. Now let's go to enterprise level. It's interesting. I wrote a blog. It was either 1 or 2 months ago. You can find either on my website or my LinkedIn profile. And I should remember the exact name, but it was something to the extent of having data literacy issues. That's good news. And the premise was this, for many years, companies, and when I would go speak with large enterprises, which I did have done for many years, you talk to them and they were just struggling with getting the data, right? Especially the early days of big data. When I wrote Taming the Big Data Tidal Wave, when you read that book now, a lot of the stuff in there, it sounds like, well, geez, that seems obvious. So that's nothing I didn't already know. But back then it was new. People were just struggling to understand what is big data and how do I even acquire it, let alone do anything with it. Then we spent years with people kind of getting it and getting more data in house, getting it available and starting to try and analyze it. And just getting some of the basics done and the more sophisticated stuff, you'd have a data science type person like me really helping curate and translate that information for business. Well, now they're ready to go to the next phase. They have the data, they understand the data fairly well, and they're ready to build on that, and they have to push more out. And so suddenly data literacy is a forefront problem. And the reason I called it good news is that you can't even worry about how people are communicating about the results and how people are interpreting the results until you're able to get the data and then generate those results. And so it's not that data literacy wasn't important in the absolute sense 5 or 6 years ago. It's that in practice, you had, what I'll call the level one issues to solve first. You don't worry about the second level problem until you conquered the first level enough. And I think what's happened is large companies now are conquered enough in terms of the data and the core analytics problems, and they're really ready now to push them out more broadly and in more automated fashion, much like I wrote about in the analytics revolution. Suddenly, then data literacy becomes a really obvious thing. Now people have analytics, they don't know how to interpret it properly. Well, that's a great problem to have because a couple of years ago they didn't have the analytics, so you didn't worry about that interpretation.
Yeah, I mean, it used to be that you had to really know a bunch of tools. You had to understand kind of complex language. You had to know R, Python, or, I mean, even back in my day, it was different, different programming
Yeah.
stuff, different languages and so forth that have changed over time. But now, you don't need to know any of that stuff. I mean, obviously some people do, but I have my MBAs use kind of these automated tools, these kind of democratic AI tools like Data Robot, for instance, is one, Big ML, there's a bunch of these things. And so on the one hand, this makes life a whole lot easier because anybody can kind of play around with this stuff. But I wonder if there's a danger there, which is the same danger you see with autonomous cars, right? Like at some level, you kind of stop you stop paying attention, maybe you stop thinking, you kind of take for granted whatever output you get from these automated tools. Um, and so, the car might kind of crash itself. Um, to what extent do you have to balance the ease of use with kind of a careful attention uh, to the dangers that lie with such automation?
Yeah, I mean, you hit on a big topic. So first, I'll point out that when you think of literacy, literacy involves the writing and the reading, let's say, or the creation and consumption. And in my mind, most business people will be focused and continue to be focused more on the consumption. And you'll have people creating things for them to consume that actually understand the nuance. I'll give you a example from just last week on this in a minute. But the example I've used, I think I first wrote about this a couple years back around should borrow the marketing guy be doing analytics, right? And the premise was there are these tools. You just throw it on someone's desktop and pray. And the funny thing is, I've learned over time, and if you think about this, you'll see the same thing. The less you know about something, the more you tend to underestimate what it takes. So if you've never uh, done high platform diving or fencing, hey, it looks pretty straightforward. You get up there, you hop off, do a few flips, nothing to it, right? But once you actually were get into those, my guess is most of us would belly flop pretty regularly for quite a while. And so the point is, in the early days of some of these automated tools, especially, people who didn't understand the nuances of analytics would just go grab them and start pointing and clicking. And the problem is with that, you really got to understand, A, what are you trying to solve and what's the data underneath? What's it valid for? What's it not valid for? What modeling methodology actually
Mm.
makes sense here? Because you can get an answer that appears to be a reasonable answer, but that has some serious flaws in it, both fundamentally from you're misinterpreting the data to ethics. Like you mentioned that last ethics book, this is a big issue. You can get into ethics problems and with what you've created and may not know it. And so I look at a lot of these automated tools more as great enablers of productivity for people who have some level of training, but that they ought not, the people should not assume just because you can point and click, you're going to get a good answer. And to give one in my real life, I'm an analytics guy, right? I'm a data science type. I can program like hell. I am not good at creating artwork or graphics. So I
Mhm.
could go get a ton of training. I mean, these Adobe professional style tools like we have at KSU are amazing what they let me do. But if I went to the marketing department and said, look, I know how to create images. I know how to combine and overlay images. I know how to export them into a brochure. Let me come work on your team. They're going to say, are you crazy, Bill? The mechanics of merging images together and formatting them on a page, actually physically dropping them onto a page, and then actually putting it into brochure format. Yeah, that's the mechanics, but the artistry behind it and the strategy behind what images should we put in, what message are we conveying, that takes knowledge and practice. And you don't have any clue what you're doing in that area. And I say, yep, you're right. I don't. I think it's the flip here too with these automated tools. It's very easy to go and point and click and get something. But it's also very easy to get something that's absolutely wrong and you wouldn't have the knowledge. And so this gets back to the data literacy then. I think the tools are also here now that I can build something rather sophisticated and share it with you who may not be very sophisticated in a way that you can still interact with and understand it. You may even be able to say, you know what? What would happen if I dropped my price 5% or 10% or 20%? And my model would be able to tell you, you see the revenue and margin implications. You're going to make a good decision. You don't have to understand all the nuances behind that model that I built, but you're still able to interact with that model. To me, that should be the goal of literacy, is have everyone focus on their strengths. And by doing that, the non-technical business people can become very strong at the interpretation and use of analytical results. And that's where I think their biggest value will be to the company, as opposed to attempting to bleed over and actually create these things themselves. So I'll pause there. I think I went on a couple tangents.
Yeah, it's kind of like I remember reading about this soldier from Iraq who went and joined a police force, and he said, we spent about a week learning how to shoot, and about 5 minutes learning when to shoot, and I thought that was super interesting that the learning how to use a tool was way more important than learning when and why to use the tool, and so you're putting a lot of firepower in the hands of people, in marketing and in operations and kind of frontline people, who don't have that background, don't have that history of building out these tools and maybe don't have a little insight into the nuance. Um, so that would seem to indicate that
Can I give you
as
one
yeah,
example real quick, by the way?
sure.
Sorry, yeah, when I realized I forgot to get, I said I'd give you an example from just this past week. Here's a real one from that capstone course. And I saw this coming a mile away because it hit me. We have a grid where we had the data for the class loaded. And initially the person who manages the grid did me the favor of just trying to, quickly load the data for me using a tool with a auto, read in data function. And it all looked really funky. And then having done this for a while, I realized, we know what almost every automated tool is going to do is going to scan however many rows the default is. It could be anywhere from a couple hundred to a couple thousand, and then decide what the format of the data is. Well, the file we were sent had some of the least clean rows that had the most missing data front loaded. And so it defined a bunch of fields as like one character fields that actually had much more. And so I knew from my experience, okay, this file obviously has some bias in it. So I need to look at all, the file more holistically and figure out what should the formats be. I can't use the auto load tool. I have to go do overrides. Sure enough, the first day of class, a couple of students come in. I'm not understanding, like, all my dates are just one number from 1 to 9. And a lot of these codes are just one letter. And from the data dictionary, it sounded like we'd be getting more. And I'm like, you did the auto import button, didn't you? And they're like, yes. I said, well, there's your problem. And that's a classic example right there. These students didn't know any better. I don't begrudge them. It was a great lesson to learn. And that's why I spent about 5 minutes kind of showing them, here's how that happened. Here's why it happened. This is why an auto import tool might be a good first pass, but you always have to inspect what was the result of that, because they'll often actually get it wrong. Maybe not as universally wrong as in this case, but there could easily be 1 or 2 fields out of the 50 that you load that get all messed up from the auto load. Now, did it help to get 48 automatically loaded? Sure, but you still have to go back and clean up those too. And that's just where you get back to, you have to know enough to know how to look for that and correct it, or else you're not going to be able to do a good job if you're only relying on those automated tool sets.
Yeah, I mean, people talk about democratizing AI, and we all know democracy has, has some costs and some benefits and some pros and some cons. And, if in order to be a participant in the democratic process, you have to have some knowledge and it's a little bit of responsibility. Otherwise, you need a kind of centralized authority to kind of control things. And it seems like companies kind of go back and forth when it comes to data governance, when it comes to who's responsible for all of the data related decision making within the organization. And for a long time, a lot of companies had these centralized data teams. And sometimes they were located in finance, sometimes they were located in engineering. They kind of moved around, but you had these centralized data teams. It seems like nowadays it's much more common to have embedded data teams distributed throughout the organization. What are the relative trade-offs between kind of having this centralized oversight? And obviously, if it's a regulated institution, you're still going to have quite a bit of that centralized oversight. But a lot of other organizations are kind of pushing this stuff out to the extremities. What are the trade-offs there?
Yeah. So look, and I'll speak from really let's call it the analytics, data science type teams, because that's where I know best. But there's been kind of a fluctuation over time. And again, when I explain why, you'll see why. But most companies started with a actually fairly distributed model and independent distribution, meaning, so as it happens, marketing teams and risk teams in finance, for example, were very early to adopting analytics into what they did. And they went and hired some folks, right, way back, and they were a standalone little team. And then some other business units over time said, hey, you know what, in operations, we've heard these marketing team has hired some good analytics people and they've been getting these results. We want to go hire some. And you ended up with a decentralized model that seems fine up until you hit a certain point. And now you suddenly have 10 decentralized teams that aren't coordinating at all, that are redundantly buying licenses for software and server capacity and all this stuff. And you go, we better get our hands around it. Then a lot of companies kind of whipsaw the other way. Let's put them all in one group somewhere. And it doesn't matter where, they've been parked all over the place. And the problem with that becomes then when it's all centralized, you kind of lose touch with those divisions, right? Someone really knew operations well, someone really knew marketing, but now they're a central team who could potentially get pulled into all that. and you're also not necessarily viewed as part of that team. And one big disadvantage there is the reality of how big companies work. When budgets get tight, you're going to protect your team first. And when the analytics people are part of your team, you're going to protect them. When they're part of a far off COE that you use on projects, they're going to be ranked above maybe a outside contractor, but certainly below your team. And so those organizations tended to have large fluctuations. And what we see now has been what I call the hybrid model. We talked a lot about this at IA, and that's where you have a centralized group that helps set a central strategy and helps manage, say, centralized resources like a computing infrastructure that all of the distributed teams can use, where you have a distributed team within marketing that can support marketing day to day that still has access to that centralized team for support. And then that centralized team can also help tackle the problems that are more of a corporate or cross-functional level. No one within marketing is going to worry about resolving this issue between marketing and operations unless it's worth enough money to their budget. But if you add up what's it worth to operations plus what's it worth to marketing, it might not be worth what it costs for either of them to fix it individually. But when you add up how much it saves the company, if it's fixed for both of them, it's totally worth it. And now you can fund that. So that's where the centralized team can help. So that mix of some centralized strategy and oversight, and as well as ability to do the bigger, more strategic projects, combined with people that are embedded that really get to know the business and work alongside those business people, that tends to be what folks have been evolving towards. And the main question there is just simply, how big is the central versus the distributed teams? And again, there's no right answer. It really depends on the workload of that given company and some of the cultural aspects of how much they prefer to have things distributed or centralized in general. But the point is, you get to some variation of that, and that's when you can really start to get some good momentum.
And given the importance of data within the organization and analytics, some companies have introduced these new roles like chief data officer or chief analytics officer. When is it justified to create someone with that role with direct reporting to the CEO? And where are you seeing this? Where are you seeing it fail? Where are you seeing it succeed?
That's a good question. So I can tell you, it's funny the way part of how I ended up with the chief analytics officer role at Teradata was we were seeing our clients start to sanction those, and we're out talking to customers about what they need to do for furthering their strategies. And I remember having the conversation with our executive team, and I basically just said, hey, we need to be practicing what we preach, right? If we're saying this is important and it needs to be elevated, it should be elevated. Now, in fairness, most chief data officers and chief analytics officers today have not yet risen to a report to the CEO level. There are some examples. A lot of them are reporting to another of the first line officers, much like a chief technology officer is often under the chief information officer. So most chief analytics officers, whether it's chief analytics officers, chief data officers, chief data and analytics officers, there's a lot of overlap in terms of how some people define those. I think we can get into this a separate topic, distinctions between them that there ought to be. But the point is, a lot of them, they may still be reporting to the COO, or they might be reporting to the CMO or the CFO, et cetera. I don't know that it's so important exactly which level of that they report to, but once you get that C title and they're reporting to one of the, primary 5 or 6 officers of the company, that's going to come with a level of influence and respect that I think is needed. Because the one example I used to always give is when no one owns analytics, effectively nobody does. So I knew companies before they chartered a chief analytics officer. I remember one large auto manufacturer in particular, I went and spoke to their, what do they term? They had a little community, and they had a much cooler name for it, but this community where they had 18 different distributed groups that were voluntarily coordinating a council. That's what they call the analytics council, to try and make enterprise level progress. And I told them during that presentation, when some questions came up, I said, well, here's your big problem. It's awesome what you're doing right now. Don't get me wrong. And you're ahead of many companies, but you have this volunteer council. I said, so what happens when everybody agrees or enough people agree, it's fine. But what happens when the vote's a tie? How do you make any progress, right? When people can't agree, no one has the authority or ability to break that tie. That's why you need somebody chartered, regardless of title. If you don't want to call a chief analytics officer, call him the enterprise vice president of analytics. I don't really care. Point is, somebody has to break that tie. Someone has to own the council. And I think that's the key we're going after here is in the old days, you could have had a scenario where um, nobody had authority to actually resolve a dispute until the CEO, quite literally. And how often does anybody want to escalate to an officer, let alone those officers to the CEO? Because say analytics and IT or two different analytics groups aren't getting along together in terms of how to go about a couple of projects. And I mean, it just didn't happen. Now, when there's an officially a CAO, that person would have that mandate to monitor such things and raise it to that attention. And so I think that that's the important thing. I always used to say we used to fight to get access to someone who had a seat at the table. I spent many years trying to get the ear of someone who sat at the table. And if you picture, sometimes you see these, like the big political meetings, like some meeting at the White House, and there's all the generals around the table, and the big cheese is looking really formal, and there's all these people around this outside of the room that come up and whisper in their ear here and there, or hand them a document here and there. We used to be lucky to get to be the person sitting against that wall and handing things over. I think the cool thing today in many companies, we actually have analytics, data science oriented people at that table now. And that's what I think this whole trend of the chief analytics or chief data officer represents. It's recognizing it deserves a seat at the table, whether it's a primary seat at the head of the table or one of the ones down the middle of the left side, at least they're officially at the table.
Yeah, but once you get to the table, you have to be able to speak the language of the table, right? And for a long
Yes.
time, I think people who are the CIO was always the kind of odd person out, right? I mean, the CFO and the CMO and the COO and the CEO, they all went to business school together, and the CIO is oftentimes this kind of engineering person, and they were
Right.
often speaking a very different language. And so what I've observed is well, a couple things. One, either the CIOs have to become more business savvy and learn to speak the language of business, or all the business folks need to start learning how to speak the more technical language. At Berkeley, we try to train people to be like the human API between the technical and the business side. That's what we like to say
Right.
about our students. But then the other thing that we're seeing is that when the CIOs or those folks fail to learn that language, then they often get kind of pushed further down, and this new kind of hybrid character, like the chief digital officer, steps in and then sort of orchestrates these connections. So is it easier to teach technical people the language of business, or is it easier to teach the business people the more technical language? We had a class here at Berkeley with half data scientists and half MBAs, and it was kind of like watching boys and girls at a seventh grade dance, for the first half of the
Yeah.
semester as they circled each other, trying to figure out like who are these people. But then when they finally got together, it was nice music.
So this gets back to the literacy thing. I think each has to be able to come enough along to the other that they can actually effectively communicate. But honestly, to fully transform a business person into a data scientist or a data scientist into a business person, there are people who are able to span that, right? But they're very rare. I mean, there's a lot of data scientists who simply don't have the interest in business, maybe, or just aren't able to get out of that super technical viewpoint. And that's okay. There's a spot for them. I think there's a lot of business people who don't have the technical background and understanding of mathematics and such to actually be an effective hands-on data scientist, but that's okay. I don't think either group should be pressured to become fully the other. They have to come far enough along that they can have a conversation with the other and then go back to their respective groups and say, okay, I figured this out. So on the business side, maybe it's okay. I talked to Bill. I'm not sure what all this AI stuff he was talking about was, but what he said is at the end of the day, if we put this on the website, when people click, we're going to be able to tell what their emotion appears to be at the moment that they click. And then we can do this and this with it. And that's what they did. And I can go back and go, I'm not sure why they care so much about this emotion or what they'll actually do from a marketing perspective with that data. But if we can build these models and we can plug it in, I know we can get them that data and it'll be accurate, right? And so over time, if we succeed on that project, we'll probably both sides come to understand the other side better. But initially, you just have to be able to meet that middle ground of, if I can get you this, will that give you what you need? Yeah, that would do it. And is there any way that you can get me this? Because this is what I think I need. Well, I can't get you exactly that, but I could get you this variation on that. Is that good enough? Okay, yeah, that's good enough. And now we're off and running. But it takes concerted effort, I've found. I've been lucky in two ways. One, I think I always kind of had a brain that naturally spanned the business and analytics side, which is why I got into business analytics back in the beginning of my career when it was not a career and it was not a cool thing to do. I've always had been fascinated by the two sides. Um, but on top of that, I've had a lot of practice and I've met with a lot of both literally in my career, I've met almost equally with, data science people, IT people who are technical, but don't have a clue about data science. And I don't have a clue about some of the IT things they worry about in terms of how the systems will be hammered by processing, and then business people. And over time, if you do practice, you will start to learn. And if I'm in a conversation, it's almost like switching when you talk to someone who's bilingual, right? You've got somebody and every now and then you're in a three-way conversation and they're really inspired. So they start speaking French or Spanish to their coworker, to the other person online who's there. And you could tell they had something they just really had to get out in their language. And then they come back, okay, now that we talked about it, here's how it comes out. That's kind of what I do. I can and you can learn to switch gears. I'm talking to the IT person. I need to talk in this specific language and avoid some of these terms more, and we can figure it out. But then when I got to translate what they said over to the business, I have to, take a few things out, add a few color commentary in that you can do from your experience. So it's something I encourage. I don't think they teach it very well in school in most cases. And maybe you get a class or two, like you mentioned, but career advice for students is when you first get out, the more that you focus on being able to span these worlds, the more value you will have for a company, regardless of whether you're the business person spanning to the science or the science people spanning to the business. Your value goes up immensely when you're someone who both sides say, I'm cool. Can we have that person in the room? They seem to be able to translate for us. That's the winning combination. And even within that, there's degrees, of course, but you want to be that person that both sides want in the room. And that will take effort on your part and practice and focus on learning those two languages.
Yeah, the course I taught was called Data Science, Data Strategy, and it was kind of trying to capture both of those things.
Right.
Now, you've written a lot about ethics lately, and data governance is another big topic that we're seeing quite a bit of discussion about. And those are two, I think they're different but related topics. What's on your mind right now in those areas? Don't give us all 97 ethics issues, but
Yeah.
really, why is it that business people are realizing right now that this is something that they need to think about? And is it something new, or is it just an extension of the governance and ethics ideas in business that people have always really been interested in, just applied to a new domain?
So it's a little bit of all of that. So let me come at it from three angles. First, the most cynical angle. Why is it suddenly getting a lot of attention? Because it started costing people money, reputation, otherwise pain. So when you go back to it, why did network security become a really big focus and become so important? Because there were some big breaches where people lost a lot of data and it cost them a ton of brand equity and a ton of real dollars in terms of either fines or otherwise fixing the problem. So there have been cases of ethical issues in the use of analytics and data that had tangible negative impacts on organizations. That gets their attention. So that's the cynical view, and that is part of it, but that's not the whole reason. So two other reasons. For many years, like if you go back, before the big data era, there were limited scope analytics being done in very targeted areas that were fairly well understood, and their purpose was fairly clean. We're building a pricing model to set price. We're building a marketing model to see who's going to respond, et cetera. And so not that there aren't ethical considerations with those, there are, but they were being done at a smaller scale. There were people involved literally building each model manually.
Mhm.
There were people involved selecting lists to market to manually. And so the ethics didn't become as big of an issue, in part because the scale of everything was small. If you keep your hands on it, no one would, it was almost very hard for you to go do something unethical without people figuring out. So what starts happening, this was tied to the analytics revolution. We started having all kinds of automation of models where suddenly we're creating a model or maybe creating a class of models. So I've seen work done and done some work in this area. I build you a couple of price elasticity models for a couple of your products. We recognize the common framework and type of input variables that are working in your scenario. Now we automate that process to create 100 more of those with only minimal oversight, where we sanity check them, but they're substantively on their own. That starts to add risk because we're not hands-on making sure everything's fine. And maybe those models are being put out in a system where people use them for multiple purposes. Now layer on that, AI suddenly comes along, which isn't transparent. So if I build a classic logistic regression or decision tree model, those are very transparent. You can look at the output of those models, and I can tell you exactly why you were rejected credit or you were given an offer. With AI, that the core tools today, they're making progress, but they're still not transparent like that. So you have all this scale of AI coming out. People don't know what it's doing. It's doing more scary things than making you an offer.
Mhm.
It's recognizing your face for some purpose that you may or may not be comfortable with. It's analyzing your voice, all these other things. And so people started to realize, boy, we got to get a handle on this. So I think it's a confluence of all of that. It became business relevant from a cost perspective. The scale required more governance and more attention. And then the new world of some of these opaque algorithms being used at scale. I mean, who doesn't say, no matter where you fall on the spectrum, who wouldn't say, wow, they want to use facial recognition to allow me through security at an airport? How far do we go with that? We might disagree on how far to go, but very few people would say, oh, we don't even need to discuss that at all. Just roll it
Mhm.
out to the maximum extent that you possibly can. And there's so many examples of scenarios like that now where analytics are really becoming, um, they're not just a little difference between a cool offer and a cooler offer. It's a difference between you getting a job and not getting a job. The
Mhm.
difference between, you getting into some club or some credit card and not. And with those big impacts now, people demand more responsibility, transparency, and oversight on how those decisions are getting made, and then needing a way. What about the inevitable mistake where there was a mistake in my data that led me to be rated very poor for whatever purpose? If I can prove that was a mistake and I should have been given it, there has to be a way for me to then get that fixed. And that's where a lot of the GDPR, the privacy
Mhm.
legislation, all these things get towards this.
It seems though that the popular conception is a little, is a little m more, suspicious than is necessarily warranted in my view. I mean, because if you're not having your decisions being made by AI, they're being made by, NI, right? Natural intelligence. I mean, they
Yeah.
are being made either way, and so it really only makes sense to compare the outcome with the alternative, which is to, often to use humans. So a lot of people, for some reason, would rather get unjustly fired by a human than unjustly fired by an algorithm. It's somehow less painful or less disturbing that way. Do you think that people are somewhat instinctively overreacting? I mean, one of the when I think about something like bias, and I'd love to hear more about your thoughts on bias. Um, when a human is, you can't tell a human to not use bias. You can't go in and kind of delete the neurons that create the bias. But if you have a fairly straightforward, simple machine learning tool, like a decision tree, you can just go in and delete that whole column, and it kind of eliminates the bias, or at least is more likely to reduce it. Um, I don't think people really understand that, and I think they just sort of say, "Hey, this thing, I don't like it. It's kind of creepy. It's kind of science fictiony, and it's I don't want it near my life."
Yeah, so it's interesting. I guess I actually think people have been under concerned about the ethics. So frankly, my this is just my personal view. I think a lot of the big technology companies' policy has more or less been, we're going to do anything that we can up until we know it's illegal. And if it's a gray area, we'll go as dark gray as we can. And then when someone says, oh, that's too far, then we'll pull back. Versus we want to make sure everything we do is legal and ethical. And if we're not confident, we're going to do some more exploration. So I think there are absolutely a myriad examples we could go through about, where I think how about this? You or I may end up disagreeing after debating it, whether it was or wasn't unethical, but it would be clear situations where there was an ethical angle that hadn't been thought through proactively and upfront. So, and I'll give you one example I use on this that ties to your comment on, is the result better? This is a really key thing, both for just generally operationalized analytics, but also AI and these opaque methods, which is, if we get better aggregate results, that should carry a lot of weight, because any model, you can go find the exception. So let's take autonomous vehicles. Every time anywhere in the world, an autonomous vehicle causes harm to a person, it makes international headlines and people talk about shutting down autonomous vehicles. Now, that's not belittling the fact that someone maybe got killed by an autonomous vehicle, but the question that should be asked, to your point, is for every 100,000 miles driven on a road, what was the injury rate for an autonomous vehicle versus human drivers? And if that rate is half as much or a quarter as much, or eventually 1/100th as much, we should celebrate that and then embrace those cars. But what you'll still have inevitably are the people who die because of an autonomous vehicle malfunction, who obviously would not have died if they had been in control of that vehicle, because it was just some kind of, I remember one example was there was a bright white truck on a road with the sun directly onto it. And so the AI in the autonomous vehicle didn't realize there was a truck there. It just looked like white space and rammed into it. Maybe the person would have avoided that, but then you have to ask how many other accidents got avoided. You can't answer that directly, but you can look at the safety rate per mile. So coming up with the metrics by which we measure what we do is really important, but this is where the ethics get dicier than simply performance. So performance-based, that's very clean and cut, what I just said. As long as the cars are safer, then everything's fine. But if we were to, for whatever reason, find that left side driving countries had 10 times worse air rate, or countries with certain temperatures, except there's a bias to it, it could very well be that you could say it's ethical to put this car on the road in the United States, but not in England as it exists today, because there's an ethical problem where it's biased against certain cultures, certain countries, or certain rules of the road that goes, above and beyond what would be acceptable. And so that's where the ethics has to become proactive, where you're not only thinking of it on the front end, but you're also doing diagnostics on the back end to make sure, is there a bias inherent in this on the back end that we could not have predicted? Or is it working in a way that appears correct and is wrong? And a classic example of this, you can go look this up on the web, and I forget the name of the study, but it was identifying wolves versus huskies in pictures. So a husky dog is very much like a wolf. And they had an AI routine that worked amazingly well. So they applied some of these routines that have been developed to diagnose what is it in the image that's leading it to decide it's a husky or a wolf. And I think everybody would assume then, oh, it's something about the facial features or the eye size, any of that. Well, it was the snow in the background, because most of the wolf pictures were taken in the wild. Wolves lived in cold climates. There's a lot of snow, and the huskies are taken in a backyard or in your living room. So the algorithm, while it was accurately differentiating a husky from a wolf, it was for entirely wrong reasons that could have entirely been gamed if someone had figured that out. So you could argue, is it really ethical then to make a decision? So imagine something that's distinguishing, some good or bad thing about your house, or about your dress, or about your action on a video. If there's a way that something completely innocent could have been interpreted by the AI as you doing something else, then that's a problem, and that has to be addressed as well. And that again, you don't know if that bias gets into the model until you do diagnostics on the back end of those models, regardless of the variables that you fit in. What you feed in might be completely ethical, but what comes out might not be doing what it's really supposed to be, and might not therefore be ethical.
Yeah, and I think that means you have to know what exactly better is. There's a great example where they looked at people who were arrested by the Chinese government and found that you could predict, just based on someone's national ID photo, whether they were going to get arrested. So all the people get arrested look very similar to one another, which is, and if you believe that everyone who's arrested is a criminal, well, then the model's doing a great job. But if you don't have any kind of ground truth, and you can't tell, and in China, 99% of people get arrested, get convicted. So we don't actually know what the ground truth is. So we really don't know whether this model is biased or not. I suspect it is.
Well, and if I recall that, I think I remember seeing some of that same study. And there was also something where a lot of people, let's say, working professionals making a good living, would tend to have that photo taken maybe with a coat and tie on, or with a nice shirt on, et cetera. And so the model in part was identifying these. This doesn't mean that there's not white collar crime, but the people getting arrested on the street for shoplifting or for mugging aren't typically going to be the person walking out of their $100,000 a year job they got out of their MBA program, right? And so the pictures in themselves was it, people would say, oh, they somehow figured out facial features of a criminal. Well, not really. It was really identifying dress. And this gets back to it. There might well be a correlation, a statistical correlation between the dress in a picture and whether you would be arrested, but it's kind of spurious. It's not, the clothes aren't really that accurate of a predictor. Someone in the suit could still be criminal. And there's so much noise in that it's still not a very accurate model, right? I'm sure that model was better than chance, but still had tons of false negatives and false positives.
Yeah.
And that's, again, there's multiple ways to look at those models. Having statistically slightly more identified properly. So now you're at, at random, it would have been 1 out of 10 and you're at, 1 out of 9. It might be statistically significant, but if it's also just based on clothing and a random correlation, it, reminds me of my classic example from Stats 101. If you took analytics on basketball games at face value and didn't do any thinking, you will find that the number of fouls a player commits is one of the highest correlated things with the number of points that they score. So a naive person would go as the coach and say, go out and foul like hell so we can run up some points. But of course, what it really is people who play more minutes will score more and get more fouls. There's that third factor there.
Yeah.
You have to understand the nuances of the data and how to apply it. And I think it's the same kind of problems we run into all these things. We have to proactively think through that, or someone who doesn't understand it can absolutely make a wrong interpretation or take a wrong action.
Yeah. I mean, one of the key points that I try to make in my data decisions class and in my other data science class is that the tools of statistics and data science actually are incomplete. Like they can't tell you if you're making these sorts of mistakes, right? I mean, if there's a lurking variable, data science won't tell you that there's a lurking variable. They won't say, hey, you need to go and find another column out there that you never collected, right? They're not going to, you don't have the tools within the science itself to know whether accuracy is the right metric you should be using, right? You need to have some kind of costs and benefits associated with the different types of errors. And that kind of comes from outside of data science, right?
Well, let me, so I agree. Let me, I'll differ from you just slightly, which is that specific model that I built today, all it'll tell me is what's correlated. Now, if I want to validate, is there causal effects there are tools to then go run experiments to purposely test. I'm going to send players in and ask them to foul and see if my scoring goes up. And you pretty quickly learn, okay, that's not working. Now that wouldn't tell you why necessarily,
right?
But you hit on a key thing though. A lot of these modeling initiatives should be, you're looking for things that are candidates for what might be causal. And if you need causality to be firm underneath your solution, you need to go then do further testing to validate that. Now, in other scenarios, you might not care about the causality as much as if it's accurate. So if I'm just making marketing offers and I'm trying to get an extra 10 cents per customer, if I'm achieving that, if I have some spurious correlations under there, I'm not that worried about it because in the end, there's not much harm. If it's a medical scenario where I'm trying to diagnose and then treat patients, that's a big deal. So I think that idea of knowing when you need it, and then this is where the business side comes in. If I went as a data scientist and naively came, I found this great thing between points and fouls, right? Now the business equivalent would be a coach or a player going, all right, man, I see where you're coming from, but that's really stupid, right? No, but that doesn't make any sense at all. Here's how basketball works. And they would then be able to suggest by their knowledge of the game. My guess is if you test if each of those are correlated with playing time, you'll find that. And it's really the playing time that's driving both of those. So what you need to go look for some other things that might correlate with scoring. That isn't the fouling, because the fouling is clearly wrong. And now we go, okay, great. Now I can eliminate that factor, or maybe it's a couple of other factors, but based on what that coach told me, I could think of a few new factors I could create, a few new features to feed into my next round of modeling as I dig. So I think that's where that back and forth between business becomes so important because, I might find a factor the coach hadn't thought of that goes, that's brilliant. That's where that whole Moneyball thing comes from, right? And the coach may look at something I create that I think is brilliant and tell me why it's stupid. But if we work together over time, we will each have some wins and each have some losses and we'll be further along.
Right. So experimentation has to be a big part of whatever you're doing in data science, but there are some environments where that might not work. At least it won't help you to understand the causal question or the underlying ground truths. So for instance, if you have this classifier which tells you what's a husky and what's a dog, and and then you go out into the wild, and all the huskies happen to be around snow, the model's going to continue to work. But if you go into a vet's office and you have the animal in the vet's office, it might not work. But you wouldn't think to stress test it in that environment if it's not an environment you encounter that often. So you had mentioned
Yep.
in one of your articles the ability to kind of audit these models and stress test
Yes.
these models. And you also said that you don't necessarily have to um, dig too deep into the data to the point where you would violate privacy and so forth. Um, what are some techniques that you can use to stress test the models and try
Yeah.
to uncover mistakes in the analytics process?
So let's start with the one about the Huskies and the one diagnostic tool, and this is where a lot of progress is being made very fast. Is There's an approach called LIME, LIME, and it's a mouthful, like locally interpretable model agnostic explanations. But the point is, conceptually, what it does, I've already got my model that's purporting to identify Huskies. I take a bunch of Husky photos, pass it through the scoring routine, but I randomly blank out parts of the image again and again and again, much like retraining the model. And on the back end, I understand the scores that I got for each iteration of the photo. And over time, you can start to understand which pieces of that photo are correlated with the higher scores. And that's how they sucked out it was the snow. So that was a
So this is really
scenario
like
where, like,
so intelligible AI is kind of uses these
yes,
techniques.
yeah. So on the back end, you build the model to your point. What the old days, you would have gone out and started using it, and then it all fell apart. Over time, you might have finally figured out, well, it seems to work outdoors, not indoors. It would take a long time. But with this procedures like Lime now, they're building procedures where you're able to test your model. So accuracy might be the wrong thing. This would be for reasonableness.
Hmm.
The model comes out and goes, oh, it's this white periphery underneath the dog's head. And
Hmm.
you're able to go, that's not reasonable. It's accurately predicting based on a classic model measurement. It's accurately predicting, but we know it's a false uh, pattern that we found, much like the basketball example. And so what you can do then is look for those patterns. Now, separately from that, I think the analogy I used was about, when you think about, let's take Coca-Cola. Coca-Cola's secret recipe is world famously locked down, and there's, I don't know, 2, 3 people in the whole world who know the recipe. So you could argue, how can we safely drink a Coke? No one knows what the hell's in that thing. Well, here's the thing. We know, we can identify all the inputs to a Coke, right? We know they're buying certain types of corn syrup, certain types of flavorings and additives. We know that the government has criteria for those. So if you're at any given food plant, as the ingredients come in, we can validate these are legitimate food ingredients that have been produced in a legitimate way. Separate from that, it's possible to look at, are there ways that these ingredients could be mixed that would cause harm? In some cases, like, I think, isn't it bleach and ammonia in your house? If you mix those, you end up with
Yeah.
chlorine gas or something, you could die. You have to be real careful, right? So,
Hmm.
let's face it, within food world, there's known things that are bad, right? And you could look and say, we're not sure exactly what proportion Coke's putting these together, but if they're using this kind of corn syrup and this flavor and all it, in any reasonable amount, this isn't going to necessarily cause a problem. Then you have the further evidence that no one's, sitting and running to the doctor on a regular basis after drinking a Coke. So the point is, we can audit and validate that Coke appears to be safe to drink. And we can all be confident in that, but they still haven't revealed the secret formula. So in an analytics world, this would be very similar to, I know I'm using this data feed from finance and this data feed from marketing and this data feed from operations to solve this problem. We know that those data feeds have been cleansed and accurate, that we have governance on those. We know how we're combining them, and we know of no reason why the way we're combining them violates any laws or any privacy rules or any ethical things, because we've kind of thought that through. We don't know what the algorithm itself actually was that's making these predictions, but much like that example with the Huskies, we can on the back end explore, are the predictions coming out biased by race or by income or by some other factor that are of relevance to us in that case. And by the way, people think of bias always being about, it has to be race or economic.
Hmm.
It can just be bias
Yeah.
towards factors that are important from a business perspective that no one else would care about. But if it's biased towards, I'm going to have more errors in my large size than my small size,
Hmm.
that could be a problem if my large size has a cost model that's much higher than my small size. I either want no bias, or I want a bias that biases towards more errors on the
Hmm.
small side. So bias, it's not necessarily, remember the real definition of bias is one group has a different result from another group, and it doesn't have to be a sensitive thing in that large, small example. So the
Yeah.
point is, we can bring all that in. I can audit that, okay, your inputs were all good. I can see your report that you don't know of any laws. Now in the back end, I can validate you don't appear to have bias on these factors that we wanted to check for bias on. So I can say that model seems to be reasonable today. Much like Coke, you don't have to give me the literal exact formulation under there that might be your IP or your secret sauce, but we can get to the point that we're comfortable.
So within organizations, a lot of investment is made in information security, right? So we have these CISOs, we have these
Yeah.
people that are constantly on the lookout for violations of cybersecurity. They also have to be on the lookout for the violation of good quality data science rules, right? Good quality data
Right.
governance and data ethics, um, for sure. I think a lot of people think that security is the paramount importance, but I think, you know, governance includes far more than just security. So,
Well, it does. And I'll tell you, even
yeah,
if for one thing, if I have a credit score, there's people starting to consider using credit scores for things that have nothing to do with credit. So there's an example. If I work at a company that is getting credit scores from a credit agency for the purpose of approving a line of credit, let's say whether I'm buying a car, a stereo, whatever it may be, you don't want someone just being able to go in and go, hey, that's really cool. We have credit scores over here. I'm going to use this to decide X, whatever else that might be. That's probably, if not unethical, certainly illegal in the terms of that data. And so that's where this governance and security comes into play. It's also that protection of data has a proper use, and both contractually, ethically, and legally, those three could be in sync or not. But the point is, there's multiple angles you have to consider, and it's important to make sure that I can't just go grab those credit scores that we have very legitimately for a very legitimate purpose and arbitrarily build them into some other process for which they're never intended without jumping through the hoops of explaining, justifying, and then making sure that we're legally and contractually allowed to use it for that way, even if we agree that it would be an interesting analytic.
you had a post with a provocative title recently that said, why it's important to be wrong. Um, and I really like that. It could be interpreted a lot of different ways. I remember I had someone come and speak in my class who had started a new bank, and he was proud of the fact that not a single one of his customers had ever defaulted. And I thought that's a problem, right? I think maybe
Yeah.
you need to figure out where exactly that boundary is. Um, we always talk about failing, and we always talk about learning from failure and mistakes here in Silicon Valley. Um, you don't always want to fail. Certainly, if you're Boeing, you don't want to fail. Um, what did you mean by saying it's important to be wrong?
Yeah. So the context, so first of all, the context I didn't use it in, but I agree 100% with you on is you have to, when you're trying to push the envelope with analytics, all everything you work or try isn't going to work. And that's okay. You're going to have some failures. Now, but my angle on that article was actually about, even if I have a successful model. So people often think about models predicting the good stuff. Hey, we're going to predict who's going to respond or which mortgages are safest. And you want to then go and maximize that. My
Hmm.
point was, what if I'm predicting something bad? Equipment's about to break or people are about to default. We shouldn't celebrate if our predictions are dead on 6 months down the road, because what that means is we just sat by and watched the train wrecks happen, right? As opposed to saying, now we know who's at risk. What can we do in the next 6 months to
Hmm.
try and get our estimate to be as off as possible because we've actually avoided a bunch of those defaults? So it gets back to your thing about measurement, right? Being academically pure and saying, I predicted 10% default and we hit 10% default after 6 months, that's awesome. My point of the article was, wouldn't it be better if we say, we predicted 10%, and we
Hmm.
know that that 10% would have been pretty accurate based on our testing, but we were able to lower that to 8%. And you don't beat up the modeler at that point. You celebrate the
Yeah.
business decisions that went out and help mitigate that. And then you could readjust the models over time. You might squeeze all the juice out of that you can, and you end up where your prediction is 5%. You're going to hit about 5, and you just know you can't do much better because there's always the person who gets sick who didn't know they're going to get sick, and you didn't know it, and they go bankrupt. I mean, you're out of luck. But that was the point about, you don't want to blindly follow the model performance metrics,
Hmm.
rather than at times trying to influence those metrics for the better.
Yeah, it kind of reminds me of the mistakes that people make with prediction markets, right? Because, prediction markets can be very, very powerful, but once people see the results of the prediction markets, then they change their behavior. And so the prediction markets often turn out to be wrong, but they're wrong precisely because they did such a good job of
Right.
predicting in some way. Well, look, Bill, this has been great. I've always wanted to kind of get you over here to Berkeley, and now we've got COVID, and we're able to get you remotely. Maybe one last question, which is,
Sure.
are you seeing a lot of spike in interest in data science and analytics in healthcare? I mean, healthcare, look, it's always been a very data intensive business, but there's been some frictions and there's been some, um, I think, lags in healthcare relative to some other industries when it comes to the adoption of these tools. Do you think that COVID, while accelerating all the other industries towards something that's more digital and more data savvy, is finally making this impact in healthcare that has been in some ways uh, less fast than anticipated last couple of years? Are you seeing that out there?
So I get it. It's all relative, right? So healthcare has been historically one of the most behind, worst data, least standardized out there. So it is an area that's getting attention, and there's a lot of progress being made. My opinion, from what I've seen, most of these healthcare, especially on like the provider, if you're talking about hospitals, if you're talking about medical facilities of other types, right? That side, they are still so far behind what manufacturing or retail or other industries are, but they're making progress. So it's all relative. They're making progress compared to where they are. Now, of course, healthcare brings together everything we've talked about. They've got big scale they've got to deal with. They've also got a lot of privacy and ethical considerations in terms of how they can use that data and what they're able to do with it, while protecting the patient privacy. But I do think that we're going to see more and more of analytics getting accepted. In fact, if I recall, it's been in the last year or so, one or two AI routines for like tumor identification in radiology or something. There's been a few things that have actually been approved for use. I don't think they've been approved that you can go just with that, but you can run it and have then the doctors sanity check it quickly. But it's been sanctioned. So we'll see more and more of these things where medicine begins to adapt it. And I think what we'll find is the back end analysis of patient records over time, the operationalization of that will be it's what we actually just talked about, change the bad outcome, will be interventions and policies that happened on the front end to mitigate or remove those negative outcomes before they even begin, as opposed to a lot of analytics going towards, making, once I'm already in trouble, how to make that treatment better. There'll certainly be some of that. I'm just saying, I think the most impactful will be where we learn enough to go out and realize, wow, based on this person's Fitbit data, plus this other data, from Facebook, plus their medical records, if we have that, and if we could just secure that, they're really at risk for X. And now we can
Right.
now we can intervene. We'll have a lot less of X, whatever X may be, whether it's depression, whether it's self-harm, or whether it's just cardiac issues, because, I've talked about having certain kind of pains and the Fitbit showing erratic nature of heartbeat. Well, anyway, the point is all of these things will come together where I think we'll be able to get more and more. But I think the intersection of the legal, the ethical, and the privacy concerns with all that, it becomes ramped up even further, which is part of what's hindering the progress. There's so many legal and ethical barriers to consider. You have to tread lightly and slowly, unfortunately.
Well, great, Bill. Thanks. Welcome back to academia. Hope you're having fun with all the students. It's a whole different ball of troubles compared to working with corporates, but appreciated talking today.
Yeah.
See you soon.
Yeah, no problem. And I'm enjoying the students. The big question is whether they're enjoying me. I guess we'll find out soon enough.
All right. See you soon.
This is Unsilo, brought to you by Alumni FM, connecting people through stories.